Thank you. Thank
Okay.
you. It feels great to be here today. So let's start with a surprising number, 460 terawatt hours. Every year, data centers around the world waste 460 terawatt hours of heat. To give you some perspective, that is enough energy to warm cities like Stockholm, 37 cities of the size of Stockholm. And in just 2 short years, that figure is expected to rise to 1,000 terawatt hours, equivalent output of energy to 35 to 42 nuclear power reactors. All of this energy is today wasted, literally disappearing into thin air. And this wasted heat represents an untapped asset valued somewhere between 50 to 100 billion euros.
Wow.
And the problem gets even more serious. Data centers with capacities of 240 megawatts and beyond are now today being built into environmentally sensitive areas in the Arctic region. The cold climate is ideal for cooling, but the waste heat, despite this immense potential, is still treated as a byproduct. We cannot continue down this path. We must stop wasting this heat and start seeing it as the asset it truly is. Today, most data centers are designed with one goal in mind: cost-efficient scale. So we build these enormous complexes with singular focus on optimizing the data capacity and minimizing the operational cost. But the waste heat, it's simply an afterthought if considered at all. At T-Loop, we believe there's a better way. Instead of following the traditional model of maximizing the data capacity first and then trying to figure out what to do with all the extra heat, we flipped that model. We build our data energy centers in existing buildings, and we calculate the optimal data capacity based on one goal: 100% heat recovery. The heat from our data energy centers is used to warm the buildings we're located in, nearby buildings, or to support the local district heating network. This way, we turn a wasted byproduct into a valuable resource, helping to lower the cost for entire communities. But heat recovery isn't the only untapped potential in a data center. Every data center has their own reserve capacity in batteries and generators, a backup system to ensure that we have enough power when things go wrong. In most cases, this reserve sits largely unused, waiting for an emergency. And here's the thing: this unused reserve is also an untapped asset. At T-Loop, we found a way to make this reserve capacity work for us and for the grid. Instead of letting it sit idle, we use it to support the grid through grid balancing and peak shaving. So by stepping in when there's a high demand or when there's an overcapacity, we help stabilize the grid and make the entire power net more efficient. So in other words, our backup capacity is not a safety net, it's a working asset. For us, the choice is clear. So we can either continue to build massive, wasteful data centers in sensitive regions, leaving billions of heat wasted in euros on the table, or we can start to think differently, seeing data centers not just as places to process information, but actually as key contributors to the energy system. So at T-Loop, we made that choice. We build data energy centers. And we believe it's time the industry does too. So let's flip the model. Thank you.
Thank you very much indeed, very much indeed. There's some clapping coming from our live audience here. A bit quiet. You could be a bit more, you could be as noisy as the people next door. There we go. Thank you. All right, they've finally woken up. Very interesting indeed. Panel, you've heard this interesting concept. It sounds like it could be almost disruptive, right? Which is quite fascinating. Um, any thoughts on scaling it, or if you need additional information to ask the scaling question? Go ahead.
How scalable is it? Meaning, how customized is each of your solutions?
Could you please
How
repeat? It was
much
quite loud.
customization do you need? So how unique are your solutions?
So we have 3 operational data energy centers today. We collaborate with the real estate owner, and we sort of create a win-win situation for everyone. So for the real estate owner, by implementing our data energy centers in their buildings, we can lower their energy costs with 30%, but also lower the carbon emission equivalents for them. So, but improve their reportings. For the IT customers, since we use less energy, it also becomes cheaper in that sense. And so, since we also have the grid balancing service, we can do this not maximizing the operational cost in that sense, because just by adding on these extra revenues, we are about 40% more higher revenue in the business model. So that means that we could actually build smaller data centers compared to what we see today when everything is becoming gigantic. What we also managed to do by that is that we can actually look for where is it extra power capacity, because today it's power constraints. It's quite hard to find power for data centers today, but we can find buildings who has actually spare capacity in the power and establish the data centers there, which means that we can scale. So I think the biggest problem we have today is actually changing the behavior with the customers. It's been a trend moving to the cloud, even though we now see a reverse one, moving back a bit. So seeing decentralized and distributed data centers as a better option than to be in big hyperscaling data centers. I think that is the biggest challenge today.
In my experience, the attitude when it comes to energy policy is always that you should have these large-scale production facilities that can produce electricity at any time you need it, and you can produce heat at any time you need it. But I think that we are moving towards a situation where we need exactly what you are talking about. We need demand-side response, and we need to utilize the excess heating and energy that is all around us, because otherwise we won't be able to use, for example, renewables as much as we would like to, because if you use the renewables, usually you need demand-side response, so you won't get the exact same amount of electricity all the time, for example. But what I don't understand is why you only focus on data centers. There are a lot of industries with excess heating and that could also participate in more of these demand-side response solutions. Do you also think about that kind of scaling?
Well, we come from the data center and the energy industry, so it was a quite easy transformation in that sense, going into data center, and instead of seeing servers, we see heaters, and we see that we can combine that. And I think also there's a lot of things in the data center industry now. I mean, the demand for data capacity is today actually exceed the number of data, the capacity we have in the data centers. So we need to establish even more, but we believe there should be another way of doing it and change the way. If we can collaborate with the power net and with the real estate owners, and also make sure that we have the data capacity where we create and where we use the data, and also where the heat is needed, because it's not needed up in the forests in the north, because there's nothing there who needs to be heated, to be honest.
Anybody else?
Yeah, I'm also curious on different aspects, or on the next wave of scaling, what your go-to-market strategy looks like in terms of other segments than where you are right now, as Maria alluded to, but also other regions or geographies. How are you thinking?
I think where we are at the moment, I mean, we opened up our first data center in December. We now have 3 in the Stockholm region, and we're growing quite fast. I think we have an important task to be here and now in the data industry and change that one to start with. We want to be the trailblazers there, and the demand is still huge. So there's a lot of room for a new player. So I think the best we can do to contribute to a more sustainable IT and data capacity is actually focusing on building data energy centers and trying to change and drive the industry to that.
Very cool.
I suppose one of the things here that springs to mind, I don't know if it's a problem or not, but I mean, you're talking about buildings and putting smaller data centers into buildings rather than these massive ones that sort of almost go in greenfield sites, right? Is there a shortage of buildings that are, say, being renovated or something to actually put your products into, or not?
We look at two things when we start to establish a data center, and that is the power capacity and the connectivity. So of course, but I mean, there's a lot of power and connectivity in the cities. So far, that is not the problem. We have a lot of interest from real estate owners who are actually coming to us and saying, okay, we have probably a good location for you.
Right. So they can put these things in their basement or something, or
yes, exactly. So and this is also good because we rent from them. So I mean, we become a tenant. So they get an extra revenue stream as well, because normally nobody wants to be in those dark spots where we want to put our data centers.
Any building owners in Stockholm or the rest of Sweden or any nearby countries that have got a bit of space in your basements and you want a data center sitting there generating heat for your building, this is the lady to speak to.
Exactly.
Yeah. Good. Just a little message. I feel like one of those American TV shows with the sponsor, you know. We're going to have to end it there. We've come to the end. Fantastic for your work, and let's see how it goes.
Thank you. Thank you so much.
Thank you so much.